We're going to start our unit on liquids and solids now. So here's a brief introduction of liquids and solids. So when we talked about gases, we talked about the kinetic molecular theory, and it's important that we understand that the kinetic molecular theory also explains liquids and solids, not only gases. So let's remind ourselves of the schematic representations of the three states of matter. So remember, with gases, there's a lot of energy. Those molecules are moving around really quickly, and they're far apart. With liquids, the energy is a medium energy, and the molecules in liquids slide past each other. And then in solids, there's low energy, there's a fixed orientation, and the molecules, remember, shake in place because nothing in nature is ever stagnant. So what compound is in all three phases right now? I want you to think about it, especially in terms of like in our atmosphere, what compound is in all three phases? So the answer is water. Water is in all three phases, and the reason why water is in all three phases, unlike carbon dioxide, oxygen, or nitrogen, is that the temperature is optimal for water to be in all three phases. So for example, dry ice, so dry carbon dioxide here, this is solid carbon dioxide, is a solid at negative 78 degrees Celsius. Oxygen is a liquid at negative 183 degrees Celsius. And nitrogen is a liquid at negative 196 degrees Celsius. Water is a liquid at much, much higher temperatures. So optimal temperatures for water to be in all three phases. So a reminder of our properties of gases, liquids, and solids. So I'm going to put up the answers to this slide, and you probably are going to need to pause it and fill in the slide here so that you can remind yourselves. We talked about this a little bit when we talked about the very first unit in measurements, and it's important to remind ourselves about the energy, the density, how ordered gases, liquids, and solids are, how compressible they are, the importance of intermolecular forces, which we will dive into further once we get back to class, and then just the thermal expansion, which means when you heat it, what happens to the volume of that solid, liquid, or gas. So remember, with a gas, it assumes the shape of the container, a liquid assumes the shape of the container, and solids retain their own shape. Gases have high energy, liquids have a moderate energy, and solids have low energy. The density is as follows. With a gas, it's very low. Remember, that's why we measure in grams per liter with density for gases. For liquids and solids, the density is high. With gas, there's almost no order. With a liquid, there's moderate order, and with a solid, there's high order. Gases are very compressible, and liquids and solids are not. So that's one of the properties of a liquid that we'll get into as we get further into the notes, is that liquids are not compressible. The importance of intermolecular forces in a gas is very low. In a liquid is medium, and in a solid is very high. And again, we'll get into intermolecular forces further once we get into more of the notes. And then when we heat a gas, the volume increases a lot. When we heat a liquid and a solid, the thermal expansion is not as much. So there's the first part of the liquids and solids notes. Make sure that you come with those ready to class. The other thing that I would like for you to do is create a test-like question for 2 or 3 of the slides that we covered here so that you can work on studying those and have that repetition opportunity. Thank you.